Okay, so now the solving with the matrix method, the Gauss-Jordan reduction method, the row-reduced echelon form. I'm going to go through it one time by hand using a two-system equation with two unknowns, and this is the only time we're going to do it by hand. After this, we'll go ahead and do it using the calculator, but you should at the very least understand what your calculator is doing, because it's actually a fairly complex process. Right, so use the Gauss-Jordan method to solve the following systems of equations. 2x minus 3y equals 25, 3x plus y equals negative 1. Clear any fractions or decimals first if there are any. There aren't, so I'm not going to worry about it. So I'm just going to go to writing the augmented matrix, making sure that I've got x terms first, y terms second, and in this equation does. And so my augmented matrix for this equation would be my row 1 and my row 2. My row 1 represents equation 1, so it's 2, negative 3, 25. My row 2 is my equation. This is row 1, this is row 2. Row 2 is my equation 2, which is 3, 1, negative 1. And there's my augmented matrix. It's a 2 by 3, 2 rows, 3 columns. And so that's the first step. All right, then the second step is the process. And again, it's a very specific setup. So the first non-zero entry in the first row we're going to call the pivot. And so in that case, that's the number 2. That's the first non-zero entry in the first row. And remember, this represents my x, this represents my y. There's a hidden equal sign that equals my constants. All right, that's what x, y, constants. And so what I want is I want to keep that x term. All right, so that's what we're going to do with the pivot. And so what we do in the next set is we're going to use the pivot to clear the column. So we're going to clear all of the x values that aren't the pivot. We're going to produce zeros. And what this is it'll remind you of the elimination method when we set that up. And so what I'm doing in words is what I want to do is I want to eliminate this x term. Right? There's a 2x and a 3x. I want to eliminate the x part. I want to keep the 2x, right? The 2. I want to get rid of the 3x. And so what I want to do is, well, I want to make the x terms in my rows, in my equations, the opposite of the same number. You can read that, number. Right, so in this case, I want to make, I've got 2 and I've got a 3, and so right now they're not opposite at all. Alright, but I can make them the opposite, so I want to make one a negative 6, and then the other a positive 6. So 6, right, 2 goes into 6, 3 goes into 6, and so I need to make one of my x values a 6, one of my x values a negative 6. So when we add the rows, because it's like adding our equations, that will zero out, eliminate that x term that I don't want, right? This is the 3 is the one I want to eliminate. I'm going to keep the other one, but I'm going to eliminate the 3x. All right, and that's in words what we're going to do. All right, so now we're going to do this. I'm going to rewrite my equation down here and go through the process. I'm just rewriting it. So 2, negative 3, 25, 3, 1, negative 1. All right, that's row 1, that's row 2. That represents x, y, constant. There's an equal to there. And so this is my pivot. Pivot means that's the one that's going to stay the same. So my row 1 is going to stay the same. It's my pivot row. But I'm going to get a new row 2 where 3 is going to get eliminated. It's going to zero out. And so to do that, I need to make my x values opposites of the same. Well, I need to make one a positive 6 and one a negative 6. And this is where there's 2 ways to go. I'm going to put the negative 6 on my row 1. I'm going to put the positive 6 on my row 2. And so to get a negative 6 on row 1, I've got to multiply 2 by a negative 3. So I'm going to take negative 3 times row 1. And then I'm going to add to it. I've got to add to it. I need to make this a 6. So I've got to multiply this 3 by a 2. So I'm going to take 2 times row 2. And I don't just manipulate the x values. That's why it says the entire row is going to be multiplied by negative 3. The entire row is going to be multiplied a positive 2. I have to be consistent. Whatever I do one part of my equation, my row, I have to do the entire part of my row, because again, it represents an equation. And so what we're going to do, and then I have to make sure when I do the addition, I only add like terms. And so when I go do this process, so I'm going to write my first row down because I didn't manipulate it at all. Alright, so row 1 stayed the same, my pivot row stayed the same. But I'm going to get a new row 2, and this should zero out. And so the check is, what you're going to do is you're going to do this multiplication and addition on every single piece of the row 2, right? This would be the x piece, the y piece, the constant piece. And so what we're going to do is for the x terms, I'm going to multiply -3 times the x term in row 1, add to it 2 times the, and so I'm going to do my work down here. So first thing is I'm going to take -3 times the x term in row 1, which was 2, add to it 2 times the x term in row 2, which was 3. This should give me my 0, right? That was my goal. That was my -6 plus 6, and that zeroed out. Right? But remember, that was the goal. But in order not to change the application, the problem, whatever I do to one part of my row, I have to do to all the parts of my row, and then I have to be consistent. I can only add x terms to x terms, y terms to y terms, constant terms to constant terms. And so the next thing is I have to take care of now the y's. So I have to do the same process with the y's. Use this same equation, but now with the y variable. So -3 times the y value in row 1, which is also a -3, and then add to it 2 times the y value in row 2, which is 1. So I'm going to get 9 plus 2, and so that's going to come out 11. Right, and then I do the same thing with the constant. So -3 times the constant value in row 1, so -3 times 25. Add to it 2 times the -1 in row 2, right? That's this process. 3 times the constant in row 1, 2 times the constant in row 2. So -75 minus 2, so that comes out -77. And there is my new row 2 where I've eliminated the x value. There is no x value in row 2. There's 0 x's, 11 y's, and a -77 for the constant. Alright, now we're going to do the exact same. Because remember I said it emulates the elimination method, and we basically walk through the elimination twice. So the next step is to do the same thing, but now with the second row. So I'm just going to rewrite this down here, the equation I had above. So I'm just rewriting it. So I'm going to write 2, -3, 25 for my first row, and then my new row 2 was 0, 11, -77. Alright, now I'm going to do the same thing with the y values. Alright, so where the y values, I'm going to use row 2. Right, this is row 1, this is row 2. Now my new row 1 and my new row 2. Row 2 is where I've got no x values, but I've got a y value and a constant. And so this is where I'm going to keep my y value, right? This is the y value I want to keep. Which means I want to eliminate this y value. I want to get rid of the -3y. I want to make that 0. I want to zero that out. And so, well, what do I have to do? It's the same process that we did in the last step. Alright, I am going to get a new row 1, which will zero out that y value. I keep the same row 2. That stays the same. And so when I go over here and I write it out, I'm just going to go ahead and write out my 0, 11, -77. Alright, that stays the same. My x value is gone, my y and my constant. And so I'm going to do something similar here. And so I've got to get a new row 1 where we eliminate the y value. And so what I have to do is I have to make my y values opposites of the same. Well, they're already opposite. I've got a -3 and a +11. Well, 3 and 11 are prime. So the only possibility is when I multiply them out. So I want to make one a +33 and one a -33. So I'm just going to multiply by the opposite. So again, this is the elimination. This is what we do with the elimination method. And so row 1, I'm going to multiply by 11 because I want to make this a -33. So I'm going to take 11 times row 1. I'm going to add 3 times row 2, right? I need to make this 11 a +33. The only way to make the 11 a +33 is to multiply by 3. And so that's the process. And it's the entire row that I have to do it to. I can't just change the y values. I have to do it to the entire row because the row represents my equation. And so I'm going to have to take 11 times row 1, 3 times row 2, and then add the two rows together. When I do that, I just have to be careful that I only add x terms, that's my y terms, and that's my constant. So only x terms can be added together, only y values can be added together, and only constants can be added together. And so again, I'm going to kind of write down the math here. Alright, so first the x terms, so I'm going to do this process with my x terms. And so it's going to be 11 times the x term in row 1, which is a 2, 11 times 2. Add to it 3 times the x value in row 2, which is 0. So it's just 11 times 2 plus 0. And so that comes out 22. And then this should come out 0, and I should check that it does. This is kind of the check step. I take 11 times the value in row 1, which is negative 3. Add to it 3 times the value in row 2, which was 11. That'll give me my negative 33. That gives me my positive 33. When I add them up, they do 0 away. So I do get the 0 in the y. So now there's no y spot. And then the last thing is to get my new constant, which this one I'll probably have to use a calculator. 11 times 25. And then I'm going to add to it 3 times the negative 77. So that one I just have to get my calculator. And there's no easy way to do it but just multiply it out on the calculator. So you take 11 times 25, add to it 3 times negative 77, comes out 44. Alright, and there is my new row 1, where it doesn't have, the y value has been eliminated. And so my first row is 22x, no y's, equals 44 constant. Actually, I could solve that equation right now if I wanted to, which is basically the last step. Right? Because that's what this equation is. This stands for 22x, 0y equals 44. This stands for 11y, no x, 0x, 11y equals negative 77. And so the last step is to get down to 1x and 1y. We want a 1, and so that's what's called row reduced echelon form, where I get a 1x, 0y, 0x, and a 1y, and then there's some constants that are in my last column. And so I'm going to rewrite my previous set, which was 22, 0, 44, 0, 11, negative 77. Okay, so this was my new row 1, that was my new row 2. And then what I want is I want to turn each of the pivots into 1. Instead of 22x, I want a 1x. Instead of 11y, I want a 1y. And so what you do is, well, you divide out each row by what will give me a 1 in the spot that I want. And so in the first row, I need to divide by 22. So I take all of row 1 and divide by 22. That'll give me a new row 1. And then do the same thing for row 2. I'm going to take row 2 divided by the 11, right? I want to get rid of the 11. I want to divide it out and make it 1. And so then I'll get a new row 2. Whatever, it's the entire row, so everything gets divided by 22. So 22 divided by 22 is 1, which is what I wanted. 0 divided by 22 is still 0. 44 divided by 22 is going to give me a 2. And so my first row is now 1, 0, 2. 1x, 0y equals 2. My second row, divide by 11. 0 divided by 11 is still 0. 11 divided by 11 is the one that I wanted. Negative 77 divided by 11 is negative 7. And so I've got, in my second row, I've got 0x, I eliminated the x. I've got 1y equals the constant negative 7. And so that will get me my solution. So the last thing is just to read the solution from that. Alright, which I'm going to write down here. So I'm going to rewrite this just to talk about it a little more. Alright, so this is the row reduced echelon form. This is the RREF, row reduced echelon form. I get down to an x, a y equals a constant. And so the first row gives me x plus 0y equals 2, which again, we write that as x equals 2, right, as there's no y. The second row gives me out 0x plus y equals negative 7, which again is just y equals negative 7. So this is middle step is just usually a mental step. I'm writing it out, but that's what that really is, right? That's a equation, just an x and a constant. The y zeroes out. And so this is a one solution case. So the solution is the point x is 2, y is negative 7. So it means my two original equations, which were way back at the beginning, intersect at the point 2, negative 7. That's the solution to the system. There's one point that makes both my equations true. And so this is the row reduced echelon form. That's this form here, where I get 1x, 0y a constant, 1y, 0x a constant. So I get the zeros and the ones. And the process is called the Gauss-Jordan reduction method. And this is what your calculator can do. All right, so like I said, I showed you this one time by hand. After this point, all right, remember earlier I mentioned the Gauss-Jordan method is easily extended technology. Excel will do it. You can do matrix reduction in Excel. Your calculators will do it. All the calculators, all the graphing calculators, 83s, 84s, Inspires, all of them will do it. You just have to figure out how your calculator, again, I'll be using my 84. But they can all do it. They can all find the RREF, row reduced echelon form, which is what we'll be doing in the following examples in the next video.